Cool, so that was probably the most time-consuming part of this process, creating all the parts, but it's worth it because we have a really nice parts library now that shows all our parts. We even have like data sheets and parameters in here that we can reference later. Capacitors, LED, resistors, 555 timer. What's next? Let's actually create the schematic. So we need to create this diagram. So what we're going to do, inside our 555 project PCB workspace, what we're going to do is right click, add new to project, schematic. So we have this libraries folder and this source documents folder. And the source documents folder is where we're going to hold all our schematics and PCBs. So created this, let's save it, and we can call it 555 schematic. And Altium libraries is the wrong place. In hardware, 555 tutorial. Awesome. Save. Now what we're going to do is click here on libraries. Make sure you're in your schematic library that you created, and we created this skillib one. I usually don't like to see this middle library column just because it's kind of redundant. It doesn't really tell you anything between the parts, so sometimes I like to hide it. Select columns. So library I like to remove. Some people like to bring other things in there. Cool. So we're in our schematic, and an easy way to navigate is through these tabs here as well. So let's add parts in. We can just double click this timer and our mouse will let us put it in. And then right click to stop putting it in. What else do we need? Our 1 nanofarad capacitor. Space to rotate. It's going to be somewhere here. Right click. 10 microfarad is going to be somewhere around here maybe. We have a 1 kilo ohm resistor, and also I think there was one somewhere here. Put it here for now. And a 10 kilo ohm. Great. So let's reference our schematic sheet. So pins 4 and 8 are connected to VCC. We can also double check in the datasheet of the part itself. So if I look up our part here, yes, the one. We're looking for the astable operation. Is it this one? It wasn't this one exactly, but it'll have the same schematic sheet, more or less. So pins 4 and 8 were connected to VCC in both cases. You can take 5 to 15 volts, so we're going to use 5 volts in our case. Pin 5 here is open. Here, pin 5 is connected through a capacitor to ground. We can see exactly what pin 5 does further up in the datasheet. Here we have 5 connected to a capacitor to ground as well. It looks like 5 is some sort of power source. Oh, it's for comparator thresholds. It outputs 2/3 of VCC, and you can use it if you need to compare to some value to regulate voltage or some other parameter. I guess it's just good practice to put a capacitor here, get rid of any transients, but it doesn't really do too much since we're not using it to compare anything. Awesome. So 4 and 8 go to VCC. Let's just rearrange this here. So we can put, I'll just drag it, put it up top, and then I'll take the IC name and put it down below. Wait, to the right actually. And then what we're going to do is place a power port. Where are they? Place power port place, and then I can do what I'm going to do is call it 5 volts, but I'm going to put a plus before it. And this just helps later when we see all our net labels that all the power rails have pluses and they'll all be grouped together. You can pick whatever style you want. I like this is ground. Where is it? I like the arrow usually. I don't know if anyone uses wave. Power ground. Yes, earth and bar. Let's stick with bar for now. It's not a big deal. Cool, so I'm going to put this 5 volts up here, and then I can use this wire command, and I'll just select the first point and then it can join into other things. So I'll connect it to 5 volts. Also connect my reset up here to 5 volts as well. So what I'm going to do actually is, let me just double check. Yeah, what I'm going to do is put another 5 volts up here, just so I have space to put my capacitor, because my 10 nanofarad capacitor is actually going to need to go somewhere around here. So what I can do, maybe leave this here for now, is put another 5 volt power port, so just copy this one, paste it, and then reset is also connected to 5 volts, and these are connected together through the net label and the global power pin. So what I'm going to do now is keep going. R1 is connected to VCC and pin 7. So this wire. Let's double check. Yeah, that's good. And R10 goes right underneath that to pin 6. Is that right? Pin 6 as well as the bottom of the top of the capacitor. So looks good. And then pin 6 and pin 2 are connected together. Bottom of the capacitor goes to ground, pin 1 goes to ground. So we can place a ground pin. And if you like right click any of these, then you can see other tools that are available if there's this little arrow kind of deal. Pin 1 was ground, yeah. Out goes to our 1 kilo ohm resistor and the diode. Where's our diode? I didn't place it. Oh. Our LED, I should say. And then this capacitor goes to ground. So I can place it something like this. So it's up to you exactly where you want to put it. This is kind of a messy spot. I might actually recommend to put it maybe somewhere here. And what you can do is just wire right over this part. And you need to make sure that you don't have these crossings, because it's super confusing as to if these are connected or not. Usually if they are connected, there'll be this big dot, but even if they are, it's really confusing to have a 4-wire crossing. So you want to always avoid this. In Altium, one thing you could do, I seem to find it, you can specify like jumping over. So display crossovers will show a little loop if they're not actually connected, like this. That's a lot more helpful to see that they're not actually connected. So we have this big schematic. It's not that big. Put a ground here for the LED. And these grounds are all connected together as well. Some people are very picky and they like all the grounds to be the same like level, but that doesn't really mean anything. Sometimes it just makes the schematic look pretty. Okay, maybe I'll bring this in a little bit. Use it as little spaces I need to. Cool. So that's almost it for the schematic. One thing we're missing is a connector, a way to get power to the board. Otherwise, this board just exists on its own and doesn't really have any way to get power from the outside world. But we'll just place some pads on the PCB so that we can solder on some wires. So one thing you may be wondering about is all these red lines and these question marks. These red lines are because the reference designators haven't been annotated yet, so that means numbered. So we promised an easy way to do that. One thing Altium has is under Tools, you go to Annotation and Annotate Schematics, and you can make sure that your schematic sheet is checked. And then all of these components are going to be numbered, so you can say Update Changes List. 7 were made, okay. Accept the changes, create an engineering change order, or eco. Validate, execute. Cool, no more red squiggly lines. All numbered now. R1, R2, R3, C1, C2, U1. Great, save. Save this. And let's just compile it to see if there are any errors. Compile PCB project. Awesome. So no errors found here. You can see all the nets that we created. Oh, that's a good one. It's really important to use net labels. It basically gives each unique wire its own name. So if you don't use that, then you get these really generic net C1, net C2, and they're not helpful at all when you're routing your PCB. So what you want to do is use net labels. So what I'm going to do is stretch this out back again. And I need to call, so this resistor is connected to 2 different points. On one side it has its own electrical connection, the other side also has its own electrical connection, and these each need their own net labels. There'll be 2 different things. So I click on this, net R22, that's this little net here. So what I need to do here is to place net label, and then this bottom left corner needs to be placed on the wire itself, otherwise it won't be connected. I also need a net label here. Here I don't because it's connected to ground, so it's the same net as ground. What else is needed? Here I'm going to need a net label. Here I don't because it's connected to the same point here. Here I don't because it's connected to ground. I will need one here. Here no, because it's 5. And I will need one here because it's not connected to anything else. Cool, so what I'm going to do is now actually give them names. So this one I can just call output. You can give them any names you want. Just make sure that they don't kind of overlap like this. And this one I'm going to call LED drive. A little more over. You can call this trigger, and you can call this one discharge. Here we'll do comparator. Okay, so if I compile it again, hopefully you'll see these nets change. Awesome, so they're actually legit nets now. They don't have random names. That's really important when you're laying out your PCB. Awesome. No errors when we compiled. If we didn't have footprints in any of our parts, we'd see a lot of errors show up. So let's just push what we have so far. Add a git init finished schematic and ready to design PCB. Push.